Let's now talk about how you name alkenes and alkynes using IUPAC nomenclature rules. Oops. So, carbon number 1 needs to be the carbon that is closest to your double bond. With alkane nomenclature, you picked carbon number 1 as the carbon closest to your first substituent. But when you've got a double bond or a triple bond, carbon number 1 needs to be closer to the double bond. Okay, so in other words, the double bond is higher ranking than the substituent. But then other than that, everything's the same. So for instance, if I've got this molecule, I could go 1, 2, 3 and get to the double bond, or I could go 1, 2, 3 and get to the double bond. So either one of these could be carbon number 1. This one and this one cannot be carbon number 1, right? Because if I went this way, 1, 2, 3, 4, or 1, 2, 3, 4. So you want to pick either this one or this one. It makes no difference which one's carbon number 1. 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6, 7. Whichever one floats your boat, they're going to give you the same answer either way. So I just went straight chain left to right. This is an ethyl group, right? That's a 2-carbon chain. This is a methyl group. That's a 1-carbon chain. So you still need to designate where your substituents are. E comes before M, so it's going to be 3-ethyl, 6-methyl. And then you just need to tell the reader where the double bond begins. So we would say 3-ethyl, 6-methyl, 3-heptene. We change the ending to ene. And it's heptene because it's a 7-carbon chain. Okay? So E comes before M, so 3-ethyl, 6-methyl, 3-heptene is our final answer. Always put your substituents first. When you've got Cis-Trans-Alkenes, what we're doing here is we're looking at how the bulkiest parts of the molecule are related to each other. So if you're comparing what's on this side to each other, this piece is bulkier than this piece. And if you're comparing these two to each other, this piece is bulkier than this piece. So if the two bulkier halves are on the same side, we call that cis. And then if the two bulkier parts are on opposite sides, we call that trans. Okay, so 1, 2, 3, 4, 5. So this would be trans 2-pentene. We need this 2 to tell the reader where that double bond begins. Begins on carbon 2. Here's 1, 2, 3, 4, 5. This is cis 2-pentene. Again, we need the 2 to tell the reader that that double bond begins on carbon number 2. And you can only do cis and trans if it's drawn in such a way that you could see that it's cis or trans. You won't be able to see cis or trans if you have a skeleton structure. All right, so here's another example. Let's look at our options. We could number 1, 2, 3, 4, 5, 6, 7 and have it begin at 4, or we could have 1, 2, 3, 4, 5, 6, 7. You want to begin numbering from the left, right? Because you want to get to your double bond with the lowest number possible. This is a methyl group substituent, so we need to designate where that methyl group is. And now we just need to decide, is this cis or is this trans? If we compare this to this piece is bulkier than this piece. And if we compare this to this half is bulkier than this half. So since my two bulkiest halves are on opposite sides of the double bond, we're going to call this trans. Okay, so we say trans, and then we say 4-methyl, 3-heptene. Right? 1, 2, 3, 4, 5, 6, 7. It's trans because these are on opposite halves of the double bond. This is a methyl group on carbon 4. And then we have this 3 here to tell the reader that the double bond starts at carbon 3. You can only do cis-trans if the molecule is drawn in such a way that would allow you to do that. A diene is when you have 2 double bonds in the same molecule, and a triene is when you have 3 double bonds in the same molecule. So here, this is 2,4-hexadiene, right? Because carbon 2 begins a double bond and carbon 4 begins a double bond. And then this is 1,4-pentadiene because carbon 1 begins a double bond and carbon 4 begins a double bond. Here's another example involving a diene. We began numbering from the right because carbon 2 gets us to the double bond versus carbon 2, okay? Well, now I've got a choice. If I begin numbering from the right, gets me to 2. This also would get me to 2. So since the double bonds are equally distant from the end, now we just need to decide who gets me to a substituent sooner. If I go 1, 2, that makes it 2,4-dimethyl. If I begin numbering from the right, it makes it 1, 2, 3, 4, 5, 6. 4, 6 versus 2, 4. Okay, you want to choose the lowest numbering possible. That's why we begin numbering from the right. Okay, so this is 2, 5. That's where the double bonds begin. But we've got 2 substituents. The substituents are on 2 and 4. So this is 2,4-dimethyl, 2,5-heptadiene. Whoops. Now when you've got an alkene that's within a ring, you want to use the cyclo prefix. And by definition, carbon 1 in a ring is just wherever the double bond begins. And if there's only one double bond in your ring, the 1 isn't necessary. But always make sure that you number so that the numbering goes through the double bond and that you're using the lowest numbers possible. So there are 2 options for how we could number this molecule. We could number beginning this way, going counterclockwise, or we could begin numbering this way and go clockwise. Why? Well, first of all, which one do we think is correct? 3-methylcyclohexene or 6-methylcyclohexene? The correct answer obviously is 3-methyl, not 6-methyl. Right, you want to number so that you go through the double bond and then lowest numbers possible get used. So we begin numbering so that our methyl group ends up on carbon 3 as opposed to carbon 6. So with this one, how would we begin numbering? We could go 1, 2, 3, 4, 5, and that's an I, like iodine. So we could go 1, 2, 3, 4, 5 and get it on carbon number 5, or we could go 1, 2, 3 and get it on carbon 3. So obviously we're going to do it that way. We're going to call it 3-iodo, and then we need to put that cyclo there to tell the reader that it's a ring, and then pentene. Okay, if you've got a ring with more than one substituent and a double bond, the same rules are still going to apply. You still want to number through the double bond, and you want to use the lowest numbers possible. So here are your options. We've got 5-chloro-3-methyl versus 4-chloro-6-methyl. Which numbering system would be correct? 5-3 or 4-6? You want to use the 5-3, right? Because the maximum number here is 5, whereas the maximum number here is 6. So we want to begin numbering. So again, so that we go through the double bond and we get the lowest numbers of substituents as possible. So 5-3 is lower than 4-6. Here's another example. This one just has one double bond and 2 substituents. So we want to number through the double bond, giving us the lowest possible numbers. So my final answer here would be 5-bromo, 3-methyl cyclohexene. And then if you've got a cyclic diene, again, you want to number so that you go through the double bonds, and the double bonds take precedence over the substituent. So we would begin numbering here, 1, 2, 3, 4, 5. Okay, we don't begin numbering here because these double bonds rank higher than this substituent does in terms of how we number. If you begin numbering here, 1, 2, 3, 4, 5, 6, that'll give you 6-chloro. But if you begin numbering here, that gives you 1, 2, 3, 4, 5 chloro. So this is 5 chloro. And now because there are 2 double bonds, we do need to tell the reader where those double bonds are located. So this is 5 chloro, 1, 3 cyclohexadiene. Normally, if there's just one double bond, you don't need to tell the reader that it's on carbon number 1. It's assumed. But if you've got 2 double bonds, you need to tell the reader where both of those double bonds are located. Now, when we get to alkynes, the nomenclature rules are exactly the same for alkynes as they are for alkenes. The only difference is we're going to substitute a YNE at the end instead of an ENE. Everything else is identical. So this would be 1 hexyne. Yes, you do need that 1 because the triple bond could be anywhere in this chain. Right? The triple bond could begin right here. So yes, you do need that 1 that's telling the reader that carbon number 1 begins the triple bond. Here's another example. We have option of how to number this one. We could go 1, 2, 3, or we could go 1, 2, 3 in terms of who gets to the double bond sooner. But because there's a substituent, we want to take that into consideration as well. So we're going to begin numbering from the left. Right, so this is 2 bromo, not 5 bromo. Okay? Make sure you understand this. It's 2 bromo, 3 hexyne, YNE ending. And here's another example involving a triple bond. You want to pick your longest parent chain, the one that gets you to your double bond soonest. Now here you could have began numbering from down here as well, right? Because it would still be 1, 2, 3 with an ethyl group. So either one would work the same. So this is 3, 6 diethyl, and then 4 is where the triple bond starts. It's a none because it's 9, and then it's a YNE ending because it's an alkyne. And those are the basics of nomenclature of alkenes and alkynes.